Today we'll be working on lesson 313, determining roots from the discriminant. And what is the discriminant? Before we discuss that, let's discuss this whole equation. Do you remember seeing this in Algebra 1? This is called the quadratic formula. And usually the quadratic formula is just another way to find the solutions of an equation. We did learn so many ways, and this is just another way. Usually it's useful when your roots are imaginary or irrational. We're going to talk more about this in lesson 314, but today we're only interested in this small part under the radical, which is the b squared minus 4ac, and which is called the discriminant. Now, why is the discriminant important to find? It's important to find because it tells me the number of roots. Do I have one root? Do I have two roots? It tells me that. And tells me the type of roots. Do I have imaginary? Do I have rational, irrational roots? It does not give me the actual roots, but it tells me the type and the number of roots. So usually that is important to find. Before we go ahead and find the whole thing, it's always good to look at the inside of the radical, which is the discriminant in this case. So this is the focus of the lesson today, to find the discriminant. First of all, when you get an equation, make sure that it's in standard form, because you need to find the a, the b, and the c. In this case, the a is 10, the b is 11, and the c is negative 6. So the discriminant, which is b squared minus 4ac, you need to plug in the b, the a, and then the c. The b is 11 squared minus 4a, which is the 10, and then times c, which is the negative 6. 11 squared is going to be 121. Negative 4 times 10 times negative 6 would be 240 plus 240, which is going to give you 361 in this case. So my discriminant, b squared minus 4ac, is, as you can see, greater than 0. So once you find the discriminant, you have to decide whether it's positive, whether it's negative, whether it's 0. So 3 different choices: positive, negative, 0. In this case, the discriminant is greater than 0. So that means if I try to graph my equation 10x squared plus 11x minus 6, I'm going to see something like this. My graph is going to cross the x-axis in 2 different spots. This is what means when b squared minus 4ac is greater than 0. It means I have 2 real roots. My graph will actually cross the x-axis in 2 different spots. Now, after you find how many roots you have and the type, you can also decide whether they're going to be rational or they're going to be irrational. Rational means the radical will go away. Irrational means the radical is going to stay. So let's try to decide whether it's rational or irrational. Let's look at the number itself, 361. Can you square root 361? Can you? What will you get if you square root 361? You're going to get 19. So in this case, we say that 361 is a perfect square. It means when I find my root, at the end, my root will not have a radical in it. The radical will disappear because square root of 361 is a whole number. So I have to add to my description and say that it's not only 2 real roots, it's 2 real and rational roots. 2 real and rational roots. So if it's greater than 0, if my discriminant is greater than 0, I know that I have 2 real roots. And if the number is a perfect square, then I know it's going to be a rational root. It means the radical will actually disappear. Now let's move on to our second equation, and it's 4x squared plus 4x plus 1. Now again, it is in standard form, so a is 4, b is 4. I think I messed up over here. This should be 4x plus 1, and c is 1. So b squared minus 4ac is going to be 4 to the power 2 minus 4 times a times c. 4 squared is 16 minus 4 times 1 is going to be also negative 16. So that's going to give me a 0. So in this case, my discriminant, which is b squared minus 4ac, is equal to 0. What does that mean? It means if I try to graph my equation 4x squared plus 4x plus 1, I'm going to get something like this. It's going to be a parabola that's going to touch, no, that's not a good parabola. So it's going to be a parabola that's going to touch my x-axis at one point. How is this going to be? So let's graph it. There you go. As you can see, my parabola touched the x-axis at only one point. So I only have one real root, and in this case, my root is also the vertex. So basically, my parabola is sitting on the x-axis. So if I discover that the discriminant is equal to 0, then I directly know that I have one real root. So far, what have we discovered about the discriminant? If I try to calculate the discriminant and I see that it is greater than 0, if my discriminant is greater than 0, it means I have two real roots. And if the number is a perfect square, it means I have two real and rational roots. If my discriminant is equal to 0, it means my parabola is going to be sitting on the x-axis, so I only have one real root, which is the vertex. So let's move on to our third example, which is x squared minus 4x minus 13. As you can see, it's not written in standard form, so you need to move the negative 13 over by adding it. So my equation in this case is going to be x squared minus 4x plus 13. The a is 1, the b is negative 4, and the c is 13. So my b squared minus 4ac, which is the discriminant, is going to be equal to 1 to the power 2 minus 4. I messed up. The b is negative 4. So let's fix that. It's going to be negative 4 to the power 2 minus 4 times the a times the c. If you calculate that, you'll see that negative 4 to the power 2 is a 16, and negative 4 times 1 times 13 is going to be negative 52. So 16 minus 52 is going to give you a negative 36. So as you can see, my discriminant, which is b squared minus 4ac, is a number that is negative, so it's less than 0. What does that mean? If I try to graph my equation x squared minus 4x minus 13, I'm going to find that my parabola is going to be somewhere up in the air, flying up in the air. It will never touch the x-axis. So as you can see, there are no real roots. There are no x-intercepts. My graph will never touch the x-axis. So in this case, I have two imaginary roots. Two imaginary roots. So your graph might touch it in two spots. So two real roots might touch it in one spot, so that's one real root, might never touch it, so we have two imaginary roots. So let's move on now to our x squared minus 3x minus 9. As you can see, it is written in standard form. My a is 1, my b is negative 3, my c is negative 9. So the discriminant b squared minus 4ac is going to be negative 3 to the power 2 minus 4 times a times c. So this is going to be 9 plus 36, which is in this case a 45. There you go. Another discriminant that is positive. So what does that tell you? That you have two real roots. It means if you try to graph this, so let's move this over to graph it, to graph this equation, I'm going to find that my graph is going to actually touch the x-axis in how many points? 2 points. That's why I have two real roots. This is what the discriminant, when it's positive, this is what it tells me, that I have two real roots, that my graph will touch the x-axis in 2 points. But there's more things to discuss. Is it going to be a rational root? It means the radical will disappear from my quadratic formula. or is it going to be an irrational root? To decide that, let's look at the discriminant, which is 45. Can you square root 45? Are you going to get a whole number? If the answer is no, I'm not going to get a whole number. It means the radical will not go away. It means I do not have a rational, I have an irrational root. So then, to be more precise, my roots are going to be two real and irrational roots. Two real and irrational roots. Because the 45 in this case is not a perfect square. The square root of 45 will not give me a whole number. So with that said, let's summarize what we learned today. If the discriminant is greater than 0, like for example the number that we found earlier, which is 361, let me make this bigger, like 361, okay, and it is a perfect square, it means you can find the square root of 361, which is in that case was 19. So if it is positive and a perfect square, then I have two real and rational roots. Two real and rational roots. So this is like a summary of what we learned. It means if I try to graph my equation is going to be like that or like that. If the a is negative, then it's going to be an upside down parabola. But in this case, my roots are going to be either fractions or whole numbers. I will have no radicals because the radical, as you can see, went away. It gave me 19. Now, what if it is greater than 0, but is not a perfect square, like the number 45 we found earlier? You cannot find the square root of 45. It will give you a decimal that never ends with no pattern. So in this case, I have two real and irrational roots. Again, if I try to graph it, my graph will either look like this or like this. So it's similar to the top one. But the difference here is that my roots are going to be radical, irrational roots. My answer will have a radical in it, okay? Now the b squared minus 4ac, when it's equal to 0, when the discriminant is equal to 0, then I have one real root. It means my graph will look either like this. No, that was not a good one. I have to touch it. My vertex has to touch the x-axis. Okay, I want you to think that it's touching it at one point, okay? And the other one also at one point. So in this case, you think about it as your parabola is sitting on the x-axis, or it's touching the x-axis at only one point. The vertex in this case is the root, okay? Now, if the b squared minus 4ac is less than 0, like in one of the examples we found negative 36, it means my graph is going to be flying up in the air or down. It will never touch the x-axis. So I don't have any real roots. You cannot actually see them. There are no x-intercepts. So I have two imaginary roots. And we did talk about how to simplify imaginary solutions. It means I will have a radical with a negative on the inside, so my answer will have an I in it, okay? So think about it. We'll discuss this more. Now, I hope that this was useful. Remember that the only thing that you need to know about this lesson is how to find the discriminant, and from the discriminant decide how many roots we have and the type of roots we have. Now I hope this was helpful. There will be a practice sheet to discuss this more. Please check it on our website, try your best to do it, and come to class with examples and questions.